welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Hi everyone, welcome to the House of ZK Radio, a focused podcast and media channel exploring everything ZK, from its fundamental principles to the latest advancements in the industry. I'm Alice, education lead at ZKM. I'm joined here with co-host Pavel, who's DevRel lead at ZKM, and our guest Hanzhi, who is co-founder of Nubit. Thank you so much for being here. We're really excited to have you.
Yeah, thanks for having me.
Yeah, thank you. I'm wondering if we can first start off with an introduction of yourself, how you got involved into the Bitcoin and then also the ZK spaces.
Yes, so basically I'm a co-founder of Nubit, and I'm Hanzhi. I'm also a PhD student at UCSB, where I do research in zero-knowledge proof and blockchain. So basically, I got into this space in 2020 and starting out in blockchain security, where I focused on identifying and mitigating vulnerabilities in smart contracts and protocols. And in 2022, I joined Visionaries, which is a blockchain auditing company, where I led several zero-knowledge projects, including writing formal proofs for Ethereum Foundation's PSE team. And during that time, I dived deep into ZK research and gained hands-on experience in blockchain security and protocol design. And in early 2023, I began exploring the Bitcoin ecosystem. And by the end of this by the end of 2023, I co-founded Nubit to tackle one of the Bitcoin's most critical issue or challenge. It's data availability. So yes, that's basically a little bit about my journey. Yeah.
Great. I like how you transitioned from first focusing on blockchain security, protocol design, and then going into the Bitcoin ecosystem, focusing on DA there. So yeah, I really liked that transition for your journey. But just to start off, I'm wondering if we can first talk a bit about how you see the Bitcoin ecosystem evolving in the next few years. I know that the Nubit team really focuses on the narrative of Bitcoin 3.0. So curious to hear what you believe that stage will enable and what's needed to reach that stage.
Yeah, so if we examine the development of Bitcoin, so the original Bitcoin system, proposed by Satoshi, is what we call the first generation, that mainly focused on purely P2P payment network, which is the digital gold. And the next generation, led by Lightning Network, Stacks, Ordinals, Bitcoin Layer 2s, it is aimed to scaling Bitcoins that go beyond just payment. And I think the third generation is machine-to-machine economy and AI agents, which will be further enabled by the computation power of BitVM, which can lead to a truly decentralized ecosystem. So basically, we have seen since the end of 2022, we have seen the whole Bitcoin ecosystem has entered a phase of rapid experiments and iteration, and we have seen Ordinals, BS20, and Merlin, these Bitcoin Layer 2s, and also Babylon, BTC5. So, and I think finally towards the the end of 2024 and the beginning of 2025, we have seen the first real-world implementation of BitVM, which is basically can enable a whole lot of possibilities, or of building smart contracts directly on Bitcoin. And yeah, I think the future is toward a more programmable and interoperable future. Yeah.
And then I want to go more into about some of the specific advantages that BitVM provides. So you mentioned that now we're able to have Bitcoin be more programmable, and we can do things like building smart contracts directly on Bitcoin. Wondering what other sorts of advantages does the Nubit team specifically utilize as part of the BitVM stack?
Yeah, so I think so there are many Bitcoin native projects, right? So including a lot of Bitcoin Layer 2s aim to solve this settlement problem. And however, if you analyze their data flow, none of them actually goes far beyond their own centralized servers. So because like getting their transactions settled on Bitcoin is not only expensive, but like technically highly non-trivial. So what can we do? Like luckily we have BitVM. So it's a proposal to basically bridge the gap by like expanding Bitcoin's functionality without changing its fundamental architecture. So basically with BitVM, developers and projects can directly verify zk proofs on Bitcoin. In other words, any computation can be supported natively on Bitcoin through BitVM. Since you can verify any zk proofs, you can basically encode any computation into zk circuits and further generate these zk proofs. And it's like the high-level idea of this of the BitVM is very easy to understand. But like since the computation power of Bitcoin's script is super limited, let's move this like heavy lifting computation off chain and only defer the validation process on chain. And with this idea, we can basically for Nubit, we can basically enable like light clients, like prove the Nubit consensus directly on Bitcoin, and also enable like new asset standard, which we call Goldinals, which is like we can remove the reliance on the off-chain or external indexers and attach the transaction or execution proof directly on Bitcoin. You can directly check on the like Bitcoin mainnet and see whether your transaction, your like inscriptions, is like successful or not. So it's a like huge leap for the whole ecosystem.
And so any computation can really be encoded within zk circuits, and through BitVM, we can natively support these computations on Bitcoin.
Yeah, absolutely.
Okay. Yeah, got it. And I also wanted to go into some more details about the BitVM compiler, which I know that you guys at Nubit that's one of your focuses. Curious to learn more about some of the current challenges that exist in that practice of translating any kind of high-level code into Bitcoin-compatible scripts. So you mentioned that there of course, are scripting limitations within the scripting language itself, and then maybe there are some space constraints that we need to think about. So wondering about some of those current challenges during that translation.
Yeah, so like just like any innovation, like with BitVM, the future definitely looks awesome, right? We have so many new possibilities, but why we haven't seen anything yet, right? It's because like making BitVM from a prototype in paper to a product is extremely challenging. And just like any programs, you first have to implement BitVM. Let's say if you pick like Grok 16 verifier in some high-level programming language, let's say Rust, and use like Arcwalk to implement it. This part is easy, as you only need to write a few hundred lines of code. And then the program will be processed by a compiler, like through an IR, and all the way down to its low-level Bitcoin script. And now, like, I hope you can understand the problem. So basically, we all know that Bitcoin script is truly incomplete. And like, if you think of the expressiveness of Ethereum or Solana, like teenagers who can express her like high, rich like emotions such as happy, sad, angry. Then the expressiveness of Bitcoin script is like a 1 year baby who only has two states, cry and not cry. So that means like translating a small program, just like Grok 16 verifier, into a Bitcoin script could be extremely large. Let's say it costs gigabytes of data. And so the last difficulty is when you want to put your code on chain. In Ethereum, it is easy because your code size is tiny, who can like fit into a few blocks. But with Bitcoin, we are talking about like elephant. Well, it's like, but like this still technically possible. Even if we can't fit the whole elephant, we can treat it like a Lego elephant. Let's say we can break it into pieces, and we can further fit into Bitcoin blocks. As you could imagine, like the whole process is extremely labor intensive, and it's even worse. Like, what happens if you have another program to encode? What if you have another verifier you want to implement? Do you have to redo the whole thing again, right? If you have a bug inside the code, right? So basically, what we are trying to do is to like develop like a proper compiler to chain that can first optimize these finite field or arithmetic by like leveraging some like properties like sparsity and like constancy, and we can basically simplify the whole like process of compiling from like a high level Rust code into Bitcoin script and further split into chunks. So yeah, I think this basically aligns well with all other teams working on this field, and it's basically I think it's the practical tools towards if we want like BitVM really to succeed.
Mm-hmm. And just on more details about the compiler that you guys developed, curious to hear about the specific steps that for the pipeline for the compiler. And you mentioned that there were certain methods to, say, reduce that program size, and then that which also involves splitting it into smaller chunks. Also wondering about the sort of cryptographic techniques that you guys chose to employ in order to simplify these computations, reduce the number of operations used. So a few questions here. I was curious about the specific stages in the pipeline, maybe some of the stages that the Nubit team decided to focus or optimize more on, and some of the reasoning behind the certain cryptographic techniques that you chose to employ.
Yeah, so for the BitVM compiler, so we are implemented in Rust. So basically, we are translating, let's say, given a like high-level Rust code, let's say written in some like artwork framework, and let's say it's a gross system verifier, and we are first translating it into MIR, which is like a middle-level representation of Rust. And based on this MIR, we will do the like our passes. So basically, we will first do like the standard compiler optimization on this MIR. So basically, like we treat these finite field operations as like primitives, and we do like the constant folding and all these standard compiler optimization. And actually, like for the like all the manual optimizations that we have done before in the BitVM repo, it's basically constant folding. So we are using this compiler to automate this process, and basically it can gain like significant efficiency, and this is actually the low hanging fruits that we have achieved. And based on that, we can add more like domain-specific like crypto optimization to it. And basically for this part, we are working with like several teams on this part, like Citra and Open Labs. So like we are still like finding the patterns that can be like further optimize this code. But for now, like constant folding is basically very efficient in like optimizing these Bitcoin scripts.
Got it. And you mentioned in the beginning that one of your main motivations with starting Nubit was tackling DA on Bitcoin. So wanted to hear more about current challenges that exist in enabling Bitcoin native DA, and some advantages that Nubit specifically provides to any sorts of applications, any sorts of new users who are trying to build with Nubit's DA.
Yeah, as for the Nubit DA, so let's take a look at the current or like the past Bitcoin ecosystem. So the whole Bitcoin system, like we have seen like hundreds of Bitcoin layer 2s starting early last year, and basically like in terms of data availability, they are facing a challenge. So if all this raw data is published directly on Bitcoin, given the Bitcoin's limited block space of 4 megabytes per 10 minutes, even if we compress the raw data to the max, it would only support a total of 100 TPS for all layer 2s combined. And in this case, the cost of data availability would be extremely high. And if we utilize some like centralized servers or like some kind of DA committees to like mitigate this data availability problem for these layer 2s, it cannot like prevent malicious behavior like data withholding attacks, and it also violates the point of decentralization. So basically, data availability is one of the urgent issues that the Bitcoin ecosystem needs to solve. Let's say if DA on Ethereum is like icing on the cake, as Ethereum itself has a pretty good data availability capability, and then in comparison, like DA in the Bitcoin is much like plays a more crucial role. And since the Bitcoin is the largest digital asset, you can call it like digital gold. So we want to leverage this great asset to build our infrastructure. So at Nubit, we try to build a DA layer that lean on the least assumptions outside of Bitcoin itself to create a highly secure and scalable DA. So every project can use Nubit and gain Bitcoin security as for DA.
Got it. And also wondering, in terms of the different components that are involved with Nubit's DA, can you shed some light onto the roles and relationships between light clients, which you previously mentioned about the validators, full storage nodes? What are the interactions within Nubit's DA specifically?
Yeah, so there are a few crucial components. So the first component is validator. So in here, the ways that we are going to implement is essentially we are going to leverage Babylon to enable the Bitcoin native staking. So the validator for Nubit is going to be the Bitcoin holder or stakers, and that means that our economic security is guaranteed by Bitcoin. And based on that, we also have the full storage node, as you mentioned. So it's our second component. You can think of it like it's storing a replica of all the data stored on Nubit, and because it contains everything, it can actually provide comprehensive information for upstream applications such as the indexer, inscriptions, press articles, and in addition to this full storage node, we also have our third component, which is light node. And for this light node, you can think of it as because they cannot store all data due to some limitations in terms of storage. They can essentially perform data sampling to at least probabilistically ensure the validity of the data. And based on these three components, we have constructed our DA layer and starting to provide services to the upstream layer 2s and infrastructures.
Just also a clarification. When you say that you enable essentially Bitcoin native security, I guess how does that differ from projects that are also doing data availability like Celestia and Avail? Is there anything that you're inheriting directly the security of Bitcoin using this type of data availability solution?
Yeah, so I think the answer lies in the authenticity. So basically, just like purchasing a genuine LV bag in Paris versus a knockoff in Beijing. So people value the authenticity and security of Bitcoin. So our design is mainly focused on how to leverage the first Bitcoin's economic security. So basically, we are using Bitcoin staking to provide this economic security, and also we are building stuff around Bitcoin itself. So with our BitVM, developers and layer 2s can directly prove that they have upload this data or make this data available on Nubit and prove it directly on Bitcoin, and which is a unique offering. And so basically with all this design around the Bitcoin itself, we can minimize the trust assumptions and be this genuine Bitcoin native DA layer.
Minimizing the trust assumptions while also inheriting native security from Bitcoin itself.
Yeah, that's right.
Okay. And I also wanted to dive a bit more into your guys' consensus mechanism, because I know that Nubit has adopted its own Nubit BFT. So I'm wondering if you can talk a bit about some of the approach behind the design considerations that were made. For example, you guys employing Comet UDP-based consensus, and then also snark-based signature aggregations. So wondering about the motivations behind adopting your own consensus mechanisms and some of the design considerations that you had to use along the way.
Yeah, so since we want to be Bitcoin native, which means other than the economic security, we also need censorship resistance. So this Nubit BFT is designed to achieve Bitcoin level censorship resistance. So the most important feature for this is to we need a high performance POS consensus protocol to support a larger validator set. And by larger, I mean on the level of hundreds of thousands of validators, which can provide a foundation for inheriting the Bitcoin's censorship resistance. And so to really achieve this, the current bottleneck for this large-scale consensus algorithm is basically the communication of overhead. So serial signature aggregation scheme, BLS, or this scheme can get us to the hundreds of validators, but with snark-based signature verification, it can get us to the this hundreds of thousands of level, and you can state a succinct proof that the majority of the validators have signed a block, and you can just broadcast this proof instead of broadcast all this signature aggregation, and there will be just linear communication of overhead when you try to scale your validator set. So we are working on this consensus algorithm mechanism with serial research team, especially Dalia from UCSB, and it's still a prototype, and we are still designing the whole mechanism, and hopefully we can release the testnet version this year. Yeah.
Got it. And you mentioned about your main intention trying to limit the amount of computation overhead. So curious to hear about some of the specific opportunities that recursive snarks provide within the signature aggregation, as opposed to maybe some of the other techniques you mentioned that are being used today.
Yeah, so today the most widely used technique is called BLS, signature aggregation, which is essentially it can allow hundreds of validators, since you need to maintain a bitmap. So bitmap is kind of it basically states whether a validator has signed or not, and with recursive snarks, you can basically recursively construct this queue qualification certificate, and basically all these signature will be aggregating to one single succinct proof, and this proof can be further broadcast to the whole network, and every participant can individually verify this proof, since it's zk snark. It's super succinct. And you can basically the computation overhead and both the communication overhead are all very low, and in this way we can basically scale the validator set. Yeah.
Got it. And also going into more details about the proofs, I'm curious to hear some of the advantages that are enabled from utilizing both optimistic and zk. So I know you guys have that kind of hybrid approach in your architecture and also in the Goldinals as well. So what kinds of capabilities that are enabled that say cannot be achieved just by using one approach alone? What are some of the advantages for utilizing both optimistic and zk?
Yeah, so basically BitVM itself, or specifically BitVM 2, is using this optimistic approach to do zk verification on Bitcoin. It is based on this paradigm, this challenge response mechanism, and it's very possible on Bitcoin. So I would say, because it's the only way that we can do this zk verification on Bitcoin right now, and we do have other ways. we have a way to verify a stock proof since it's hash based, and but like just like what Stockware did for say like Bitcoin stock verifier, but this verifier require like OPCAT, because like there's no way that you can combine two data on stack currently without an OPCAT, and which means that if you want to like directly using this like hash based zk scheme, basically you need to implement the hash function in Bitcoin script instead of just use like its opcode, and this part is like it's not practical, and you cannot fit it into like any given limit. So so I would say it's because it's the only way we can do this CK verification on Bitcoin, and it do have like some downside, but we are like basically we are getting there. Yeah.
Mm-hmm. Got it. And I also wanted to go into some more details about some of the new releases that you guys recently had. So I know you guys relatively recently launched the BitVM IDE. So wanted to hear more about how it contributes to the developer experience. What sort of gaps exist in current development tools, and how does the BitVM IDE simplify that experience when developers, when users are trying to write and verify proofs on Bitcoin?
Yeah, so BitVM is complex. As we discussed before, its architecture and its implementation are both very complex. It's hard to understand. And so for BitVM IDE, it's more like an educational product. It's the first development environment for verifying zero knowledge proofs on Bitcoin. So developers can basically create complex and like secure applications without understand the underlying BitVM details. So basically, it lets you to write zk circuits and verify zk proofs, and you can like basically like without writing any like underlying BitVM code, you can submit your proof to the Bitcoin network and get it verified. So and based on this, we can basically like have more developers to basically just build on this ecosystem, and with these developers, we can create more like consumer-facing applications and further like get more adoption for this BitVM stack.
Mm-hmm. So you're providing like a very streamlined way for developers to create zk circuits and then verify those proofs on Bitcoin without having them to go through, say, like a huge learning curve with learning how to write zk circuits and knowing all of the, say, underlying cryptography behind them. It's just an accessible way for any kind of developer to be able to create and verify these proofs on Bitcoin.
Yeah, I think like we think you don't need like a PhD degree to build on Bitcoin.
Yeah, definitely. And I also wanted to know a bit more about your guys' indexer architecture. So how does it compare to, say, some of the traditional decentralized indexer networks that currently exist? And wanted to also hear some of the reasoning behind certain design choices that you guys made. So, for example, I know you guys utilize these polynomial commitments during the verification portion, and then also some hash tree techniques as well. So wanted to hear a bit more about the design details and the choices behind your guys' indexer architecture.
Yeah, so basically, this indexer is a stateless execution layer for meta protocols like BSC20. So the reason why we are building this indexer is because like back in like 2020, early 2024, the BSC20 is like absolutely dominating the whole market, and but like it has a very significant like I would say design flaw. So basically, it relies on like a centralized indexer to tell you your balance. Basically, if you want to know whether you have like BS20 or not, you need to query a centralized provider, and you need to fully trust them, because there's no way that you can know whether the state is true or not. And you can like run your own indexer, but it will takes like weeks or like maybe 3 or 4 days to fully index the whole blockchain. So it's really hard for like ordinary users to run this kind of indexer, and we think that it is like pretty centralized. And since you need to each time you need to like transfer a balance, transfer a token to other person, you need to query this indexer, and this indexer is fully trusted. So for this modular indexer, what we are trying to do is to provide a light indexer. So besides the full indexer, we want to have a way that users can directly verify the correctness of this full index's results. And to do so, we can we leverage this KGG commitment, and it's especially this like virtual tree. So basically, for the virtual tree, it can enable the stateless computation, which means you don't need to have the full state, but you can just have a state commitment, and you can have the current data that need to be executed. Let's say a Bitcoin block, and you can just combine the data and with this state commitment and directly statelessly compute the output, which means for a light indexer, users can directly run it on its own wallet, and whenever they need to verify the correctness of the result provided by some full indexers, they can rerun the current state and in a efficient way. So in this way, we can provide we can remove the trust of these centralized parties for BS20, and this infrastructure, I think it's critical for for ecosystem to really mature, and we have already integrated this indexer with Unisat Wallet. There's a version of Unisat Wallet that supports this verification process, and so the user can directly click verify, and all their balance will be verified through the process I've discussed before. Yeah.
Got it. So really also simplifying that user experience as well with your guys' modular indexer implementation. Mm-hmm.
Yeah.
Got it. And I wanted to go into some more details about the Goldinals that you guys are currently working on. And I know you guys also recently released a white paper about this as well. But first wanted to hear some of the drawbacks of current standards on Bitcoin. For example, we talked about these indexers, but about the use of these off-chain indexers and some of the trust assumptions that are involved there, and how Goldinals specifically try to address these kinds of challenges for these current standards.
Yeah, so Goldinals basically, Goldinals is another way. So for the modular indexer, we are trying to optimize the current standard. That we don't touch the current standard. We keep all the the procedure as it is, and we directly optimize the off-chain part, this indexer. And for the Goldinals, since it is a standard, there's a new standard, we can basically design it's in the very beginning and in a proper way. So basically, we enforce the execution proof together with each transaction, so that you can directly check whether this transaction is failed or not. So with this features enabled, we can remove this indexer. We can basically minimize the reliance on this off-chain component, since you can directly check on the Bitcoin mainnet, and that's what we call it. Why we call it it's a trust minimized token standard on Bitcoin. And also it is designed to be the like unified protocol for Bitcoin assets. So basically, like today, like Bitcoin has, I think it has dozens or like even hundreds of asset protocols. It's all like fragmented, and each time, like every time you need a new feature, it requires building a new standard, a new protocol from scratch. You need to implement a new standard and get it integrated with wallets and have its marketplace. So for Goldinals, we want to like unify all these asset standards so that developers can like build easily. Basically, they don't need to worry about how to get it to be integrated with some wallet providers. And to do that, we are doing this by enabling the programmable feature of Goldinals. Basically, since Goldinals is based on zk proofs, so each transactions like is attached by like a zk proof, and this the zk circuit or the verification key, the verifier of this zk proof, can be like changed when you are like deploying a token. So basically, you can use this feature, use this zk proof to enable any like arbitrary or like programmable asset types. So with this, it can basically let you create like stable coins, like BTC-backed assets in some like more decentralized way. And yeah, and basically it's here to make Bitcoin stronger and easier for developers to build native asset class.
So for Goldinals, it's unifying kind of all of these standards into a single kind of protocol. And by utilizing zk proofs, you can enable all of these applications that are not possible just by utilizing Bitcoin alone.
Yeah, so true.
Got it. And okay, yeah, that makes sense. And also wanted to hear some more about some of the implications with Bitcoin covenants. So what are the implications of implementing these covenants to Goldinals, and what kinds of maybe some factors that plays in, say, trust minimization? But just wanted to hear some more about the implementation of these covenants.
Yeah, so basically, Goldinals need these covenants. So it's because like BitVM also needs covenants. So basic covenants are some like defined rules for how Bitcoin can be spent in the future. And right now, covenants like say aren't support natively on Bitcoin. So we are using some like multi-signature committees, but like these do add some like trust assumptions, which Bitcoin aims to avoid. So so for like right now, like the covenants is like this feature is basically we all want that. Like if you are building on this space, if you're building BitVM, if you're building Bitcoin staking, you definitely want covenants, because without it we cannot build. We cannot build anything, and there are like there are some ways to do that, but they all require some kind of soft fork. So so currently the only possible way is to use some multi-sig committees to enforce this spending condition.
Got it. And wanted to go into some more of the types of use cases that can be enabled with Goldinals that weren't previously possible. So you mentioned briefly before about like issuing stablecoins, but what are some of the other types of use cases that you personally see have a lot of potential that can be enabled using Goldinals?
Yeah, I would say the most promising one is stablecoin. So basically, we are working with Yala. Yala is a Bitcoin native stablecoin. So they are building a stablecoin with Goldinal standard. So Bitcoin has its like very limited culture. So it's very limited in DeFi due to its like Bitcoin script capabilities. So with Goldinals, with all these BitVM features, like we can move forward to like enable this, like basically for the current Bitcoin stablecoins, they are relying on some centralized components such as multi-sig, like custody, all these kind of centralized committees. And so Yala is basically, they are combining this BitVM and zk proofs to enable trustless stablecoins on Bitcoin. So it basically maintains the Bitcoin security while enabling this stablecoin functionality. And I think this is one of the most promising like way of utilizing this Goldinals standard and BitVM. And there are also some kind of use cases such as trust minimized bridges. And I think there are like quite a few projects that are working on this direction, such as Open Labs, Citria, and Fiamma. So they all try to implement like trust minimized bridge with BitVM, which is huge because like if you think about it, we have dozens of layer 2s last year, but none of them are using like Bitcoin native technologies. So with this bridge, with this trust minimized bridge, we can finally have true rollups, which means it's just like the what rollup is on Ethereum. And yeah, I think the use cases are basically the possibilities are endless, and really looking forward to see like who can ship these products in the next few months.
Got it. And also going into some more details about the architecture, I wanted to hear more about the role of zkOracle and how you guys use it to leverage zk proofs for verifying like the execution history within these Goldinals, and also wanted to hear about some of the implications that are brought with potentially decentralizing zkOracle. So just wanted to hear about some of its roles and maybe some of its implications for any kinds of future plans that you guys have.
Yeah. So since Goldinals is heavily relying on this zk proofs, so each transactions you need to attach a zk proof to it, and to basically to get these zk proofs, you need a zkOracle to provide the reliable state, the provable state. Since like if you want to prove that your transaction is correct, you need to first prove that the like your past transactions, your past balances, and this can be only done in like this zkOracles. And so basically we are working with Succinct to have this Oracle zkilified. So basically like you can call it like zk indexer or zkOracle, it's all fine. And so basically I think like the most efficient way to implement this zkOracle is to use zkVM. So we don't want to write these zk circuits, like these low-level zk circuits, like Circom or Halo 2. It will take years, or like in the best case scenario, it will take months. And so basically, we are working with Succinct, so we can directly write those like Rust code, and it can be further translated into their zkVM and generate zk proofs. And with that, we can have the zkOracle, and we can prove that each transaction, the transaction state directly on Bitcoin.
Got it. So proving these kinds of past transactions can only be enabled with zkOracles. And you guys are using zkVMs as a means for kind of efficiently generating these kinds of proofs without having to like handwrite the underlying circuits, which as you say would be very time consuming.
Yeah, it will take years. Yeah.
Mm-hmm. And okay, yeah, that sounds great. And also was curious about, because I know that you guys have a couple of stages within its workflow. So you guys have like a prepare, a kickoff, and then also a challenge phase. So what are some of the guarantees that are provided in each stage, and what was the intention behind providing these three stages within the workflow?
Yeah, so that's basically the workflow of BitVM 2. So I can explain it more. So basically, Goldinals implements are like a general purpose state machine for Bitcoin using these three states. The first is prepare. So basically the sender posts a transaction specifying a desired state transaction. And then there's kickoff. So the sender can submit a second transaction containing a zk proof, validating the proposed transaction. And this will rely on like zkOracle to provide the desired zk proofs. And the third phase is challenge. So a challenger can review both transactions, and like if necessary, they can submit a challenge transaction, and it will trigger BitVM to finalize the correct state transaction on chain. So with these three states, these three steps, you can basically ensure it is basically trust minimized. Everyone can be the challenger to challenge the current state transaction, and everyone can propose a state transaction with zk proofs, and that's basically how Goldinals works. And yeah.
Mm-hmm. And just scoping out a bit, I wanted to hear some more about your thoughts about the general, if you have any kinds of predictions for the evolution of the Bitcoin ecosystem in the next couple of years, and how Nubit's role may evolve with that as well. So do you have any sorts of predictions of maybe some new challenges we'll discover, or new challenges that we'll address in the next few years, and also how Nubit will evolve as well?
Yeah, so I think since the end of 2022, the whole Bitcoin ecosystem has entered a phase of rapid experiments and iteration. So over this journey, we have witnessed several major milestones like Goldinals, Bitcoin Layer 2s, and recently the launch of BitVM. So with all these infrastructures getting more mature, we can finally see build the killer applications on Bitcoin. So before that, Bitcoin is just like a digital currency. We want to move beyond this currency. We want to make it we want to make it the foundation for the new internet. So in the coming years, we can see with this BitVM, with this smart contracts on Bitcoin, we can enable so many use cases, and these use cases can be I would say, since the Bitcoin is the largest crypto asset, the selling of these use cases can be much more much higher than the existing ones.
Yeah, and I really like how you mentioned that, like before, Bitcoin its use case was only within the digital currency realm, but now with these kinds of new use cases that can be enabled, we're now, as you mentioned, forming a foundation for a completely new internet. So really liked how you mentioned that. And just before we close today's session, I'm wondering if you guys have any announcements that you'd like to make, or if you personally have any sort of advice or final words to the audience for today.
Yeah, so basically, here's the alpha. So basically, we will release the Goldinals mainnet next month. So stay tuned. Yeah.
Oh, next month, coming very soon. Very exciting.
Yeah, very soon. So we have an internal devnet and internal testnet with our partners to get it integrated with several wallets, and we will release the mainnet and marketplace next month.
Got it. All right, very exciting. And yeah, I really appreciate you, Hanzhi, for joining us and for speaking, especially about some of the motivations behind the design considerations that you made, like with incorporating constant folding to optimize for the script, and then how you guys used the snark-based signatures, which enables for lower computation overhead and allowing you guys to scale the validator set as well. and then also some of the implementations that you guys have with the Goldinals as well. So I appreciate you for offering all of those insights. And yeah, thank you so much, Hanzhi, for joining us.
Yeah, thanks for having me. I really enjoyed it. Yeah.
Yeah, thank you so much.